Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.7, absolute value inequalities, video 2, less than inequalities, part 2. In the first video in this series, we defined what we meant by less than inequality, and we established a technique to solve it. Here's a summary of that. To solve an inequality of the form, absolute value of an expression is less than a number, asterisk. Rewrite the inequality as a double inequality of the following form. Negative number is less than expression is less than number. Continue solving. Express your solution in interval form, Express your solution in interval form as well as a number line. And just a reminder that the number is positive, so we'll throw that up there. But this raises a few questions. Number one, what if my inequality does not look like this form? Ooh, didn't mean to move all that around. What if the inequality does not look like this form? Number two, what happens if this number is not positive? And really, those are the only two exceptions. So let's take a look at all of those, shall we? Starting with what happens if the inequality is not of that form. Solve the inequality. Write your solution in interval form. Draw your solution on a number line. There's actually two issues with this particular less than inequality. Number one, it doesn't say less than. It says 4 is greater than the absolute value of 2k minus 3, followed by plus 1. And number two, the absolute value has some extra numbers on the outside of it. In the very last video, we're going to summarize all the moves for solving both an absolute value less than inequality and an absolute value greater than inequality. But for now, let's focus on the fact that this is not in the form that we want it. What form do we want it in? Well, we kind of want it in this form. Absolute value of an expression on the left is less than some positive number. We don't have that yet. We don't have the absolute value on the left, nor is it by itself. So how can we fix both of those things? Well, the first thing we should do is isolate the absolute value. So we'll start that as our first move. Isolate that's supposed to say answer, ANS. Isolate the absolute value. Let's fix that. And we'll put first in front of that because we should really do that. All right, so if we're going to isolate the absolute value, then we need to do the move that would get the absolute value by itself. And I think that move is fairly obvious. Let's take this line thickness down a notch. 4 is greater than the absolute value of 2k minus 3 in the absolute value and then plus 1. If we want to isolate the absolute value, that means that we want to get rid of any numbers that are on the same side of the absolute value, but outside the absolute value. We need to get rid of the plus 1. And to get rid of a plus 1, of course, we use a minus 1. Subtract 1 from both sides, and that will give us 3 on the left, greater than. On the right, the ones cancel, leaving us the absolute value of 2k minus 3. So that fixes the absolute value not being isolated issue. But if you'll notice, it still says greater than or not less than, and our absolute value is on the right side instead of the left side. So what do we do in that case? Honestly, just turn it around. Although there's nothing technically wrong with this inequality as is, when you're solving an inequality, it's almost always more intuitive if your variables are on the left and not on the right. In this case, it's sort of, for lack of a better word, backwards. So to reverse the entire inequality, just write it the other way around, but reverse the sign. In other words, we're going to change it to a less than problem. And this is pretty easy to justify because if you were to write this out in words, it would say 3 is bigger than this, or 3 is greater than this. But if you want to rewrite it so that the expression in the absolute value begins the sentence as the subject of the sentence, then saying that 3 is greater than this is the same as saying that this is less than 3. So I'm going to rewrite this from right to left as a less than problem. So absolute value of 2k minus 3 is less than 3. Both say the same thing. 3 is the bigger entity absolute value of 2k minus 3 is the lesser entity. But the advantage to reversing the entire inequality and reversing the sign is that what we're looking at now, the absolute value of 2k minus 3 is less than 3, is precisely the form that we wanted in. Absolute value of an expression is less than a number. So I reiterate, when you're solving an absolute value less than inequality, well, first off, if the inequality is not isolated, if the absolute value is not isolated, you should do that. And secondly, if after doing that, your absolute value is on the right side of the inequality, I would reverse the whole thing and put the absolute value on the left side. At this point, it's in the proper form, and so we can continue solving. Remember, to solve absolute value of an expression less than a number, you simply put that number between, almost wrote X out of habit, you put that expression between -3 and 3. So in this case, the absolute value of 2k minus 3 is less than 3 would be rewritten as -3 is less than 2k minus 3 is less than 3. And then when we proceed to solve, keep it in mind that when you're solving a double inequality, your goal is still to get the letter by itself. But now it goes whatever you do in the middle, like add 3, you must also do to the left and to the right. Adding 3 all the way across to the left, middle, and right will give us 0 on the left is less than 2k in the middle because the 3's cancel is less than 6 because that's 3 plus 3. And then, of course, to finish it, we would divide everything by 2. And that would give us 0 is less than k is less than 3. Our number line, we would shade between 0 and 3 with parentheses, since it says less than or equal to, since it just says less than. And the interval would be parentheses 0, 3, close parentheses. So 2 things to take from this example. Number 1, if the absolute value is not isolated, isolate it first. And number 2, if the absolute value is on the right side, you can reverse the entire inequality by switching the left and the right side and turning the sign in the middle around. And then proceed. But these aren't the only issues with less than absolute value inequalities, because we still haven't addressed what happens if this is violated, if the number is not positive. Well, be careful. Not positive doesn't necessarily mean negative, because it could be negative or it could be 0. So we're going to look at both cases where this number is negative and this number is 0. Let's start with when the number is negative. So what happens if that number is negative? For example, if we were solving the absolute value of 5x plus 3 is less than -4. Well, you could try to proceed like you normally would, which is to put the 5x plus 3 between 4 and -4. But think about what this problem is asking. This problem is asking, what number can you multiply by 5, add 3, and then take the absolute value of and wind up with something less than -4? That can't happen. Remember that absolute value on its own is a distance measurement, distance from 0, which means that absolute value is either 0 or positive. So why is that a problem? Well, let's see. Recall that absolute value measures distance. Let's fix that. And therefore is always positive or 0. It can't be negative, but it can be 0. No positive numbers or 0 can ever be less than a negative number. Just think about it. To be less than, then on the number line, you have to be to the left of something. So if I were to draw a number line, put a negative on it. Let's say -4. To be less than -4 means that you would have to live over here. There's no way this could live over there. Why? All the numbers to the left of -4 are negative. but absolute value never comes out negative. So what does all that mean? That means we're asked to find something that is impossible. So the conclusion is, once I've corrected the spelling of positive, the conclusion is, therefore, this inequality has no solution, which will actually always be the case when you have an absolute value less than a negative. In fact, I'm going to write that on the next page in all caps. All caps, please. Any inequality of the form absolute value of an expression is less than a negative. Let's actually take the caps off of that because it looks funny. Let's spell negative correctly. And let's drop this down, put some space there. Any inequality of that form will always end with no solution. Absolute value is non-negative. There's no way it can be less than a negative number. So that's nice. It shuts it down before it begins. So what's the solution to this? Well, we've kind of already let the cat out of the bag, but let's just go ahead and put some closure on this problem by actually writing the solution, which is that there's no solution. So answer, no solution. No real numbers work. So that's what happens if that number is negative when you're doing an absolute value inequality. Well, what if it's 0? Now, if it's 0, then it's one of two things happens. So we'll just take a look at both instances. Last time I checked, the word number does not have a V in it. What if the number is 0? Well, I've got two very similar except very different problems. One is the absolute value of 5x minus 1 is less than 0, and one is the absolute value of 5x minus 1 is less than or equal to 0. Does it matter? Absolutely. Because think about what the first one is asking you for. The first one is saying that this absolute value is to the left of 0 because it says strictly less than. So if I were to draw a number line, put 0 in the middle. One second, folks. Try that again. If I were to draw a number line, I want the line a little bit thicker. There we go. And put 0 in the middle. Then we're saying that 5x minus 1 has to be over here, but not 0 because it's strictly less than. Well, the numbers that live to the left of 0 are all negative, and there's no way an absolute value can be negative. So in this particular instance, there would be no solution for the same reason as before. Absolute values can't be negative, and this would require it. Now, by contrast, look at the second one. The absolute value of 5x minus 1 is less than or equal to 0. Remember, less than or equal to is really two problems at once. It's absolute value of 5x minus 1 is less than 0, or the absolute value of 5x minus 1 is equal to 0. Now, we already know what happens here because that's the same inequality as over here. So that part has no solution. But what about the other half? Absolute value of 5x minus 1 equals 0. Well, absolute value is non-negative, meaning that it always comes out positive or 0. And specifically, the only way an absolute value can equal 0 is if the expression on the inside is 0. Think of it in terms of distance. The equation in the green box that says absolute value of 5x minus 1 equals 0 as a distance issue is saying that the expression 5x minus 1 is 0 spaces away from 0. Well, that would put it at 0. So that means that for this one, we would write 5x minus 1 is equal to 0 and get x is equal to 1/5, which we really can't write as an interval. And as a number line, all we would have to do is find 1/5, put a filled-in dot on it. So it's actually a single value when you have an absolute value less than or equal to 0, or rather I should say, to find the solutions of absolute value less than or equal to 0, you just put the expression equal to 0 and solve it. All right, so I think we've covered all the bases here. Let's see. Yes. So let's just summarize everything we know about solving an absolute value less than problem. All right, So number one, if necessary, actually, let's title this, how to solve absolute value of an expression is less than a number. Sorry, I'm freezing up here for a second, folks. How to solve absolute value of an expression is less than a number. Number one, if necessary, comma, isolate, well, let's just say manipulate. Can't type today. Manipulate the inequality until it has this form. And when I say this form, I mean two things. Number one, isolate absolute value is isolated, and number two, it's on the left side of the inequality. Both of which we discussed here about isolating the absolute value and reversing the entire inequality, including the sign, to get it in the form absolute value of an expression is less than a number. Okay, so we're currently doing this. All right, number two. If the number is positive, rewrite the inequality as a double inequality of the form negative number is less than expression, which is less than number. Solve. Okay. Number three. If the number is negative, there is no solution. Number four. If the number is 0, there is no solution if the inequality is strict, meaning it's just less than. If the inequality is, for lack of a better word, loose, and when I say loose, I mean less than or equal to, I'll have to draw a line underneath in just a second. You solve expression equals 0. Let me draw that line underneath there. Okay. And by the way, all these steps, all the steps above also pertain to less than or equal to inequalities. So if I had an equal to or equal to there, I would still do the exact same things. The only time where it really makes a difference is when it's 0, because sometimes there's no solution if it says less than 0. And sometimes there is a solution if it says less than or equal to 0. And I'm not 100% sure that the word loose is the best word here. I think there's a better adjective for an inequality that allows it to be equal. But I know that this one is called a strict inequality because it does not allow it to be equal. Nope, it must be less than, no equal, less than only. So this one we'll just call loose. And I believe that wraps up this video.